If you recall from our analog electronics module, pulse width modulation, or PWM, could be used to effectively control a voltage level by turning the voltage on and off really fast. Now, this is basically a digital function. The voltage is either on or off. How long the power stayed on, or how long the pulse was, dictated the average output voltage. If the pulses were 5 volts and the duty cycle was 50%, then the pulse was only high 50% of the time, and so the average voltage was 2.5 volts, or 50% of the 5 volts peak output. So PWM could be used to control the speed of a motor, or the brightness of a light. The Arduino Uno has multiple PWM outputs, and they are marked with the tilde, that is the squiggly dash. PWM is available on pins 11, 10, 9, 6, 5, and 3. The Uno does not have a digital to analog converter like the PIC. Yet, to use the PWM on the Arduino, you use the analog write function. That looks like this. The instruction, notice the capital W, then in brackets the pin number, a comma, and then a PWM value between 0 and 255. 0 is off completely, no pulse, and 255 is on all the time. Now, I'll be honest, I don't like the way they did this because this is not an analog output. It's a pulse width modulated output. It's just not the same. So why use an instruction for analog writing? But that's the way they did it. So we'll treat it as an analog output because that's the way they treat it in Arduino. We'll start off by loading up an example sketch called Fade. So this is under File, Examples, Basics, and Fade. Now the first thing that they did was to set up some variables. Look at that, you know what those are now, and how they work, and that these are global declarations. So the first variable, LED in all lowercase, is actually the pin number the LED is going to be connected to. Now notice that the onboard LED is connected to pin 13, and pin 13 does not have PWM available as one of its functions. So we have to use a different pin. One of those pins which has PWM, we'll use pin 9. We then set up an integer called brightness, and this will be the PWM number between 0 and 255. We then set up a third variable called fade amount, and notice the capitalized A. That's important to remember if you rewrite or modify this sketch. And we're going to step through the numbers 0 through 255, incrementing by this amount. So we'll step from 0 to 255 in steps of 5. We then set up pin 9 as our output. Remember, that's our variable LED we set up. So we set it up as 9. So this sets up pin 9 as an output. And we then get to the loop function. We perform an analog write on pin 9 and write whatever value our brightness is. Now, because we're just starting off, it's 0. So the LED will be off. We then perform a math function using our variables. We add whatever our fade amount is, in this case it's 5, to whatever our brightness value was. So now our brightness will be 5. When it loops back, it'll send out an analog write of 5, so just barely on. The next time it loops around, it'll send out a PWM of 10, etc. So the brightness gets brighter every time it runs through the loop until it hits 255. That's when this next line comes into play. We run a check on the brightness variable. We're going to count all the way up to 255. Then we want to count down to 0. So we check here if it's 0 or less, or greater than or equal to 255. If it is, then all we do is we take the fade amount variable and we make it either positive or negative. It equals whatever it was, but with a negative in front of it. If it's positive 5, then it becomes -5. If it's -5, then we add a negative to a negative, you get a positive, right? So it will become a +5. So in our case, we've been counting up from 0, adding 5 every time we went through the loop. We hit 255, and now our fade amount gets set to -5. So now every time it loops through the loop function, it will subtract 5 from the fade amount, or from the brightness. We're adding a -5, right? So load up your sketch and run it. Now the camera will hopefully pick this up all right. The iris on the camera will try to adjust for different light intensities. So hopefully you'll actually see the light fading properly. Now another interesting experiment you can do, which again I hope the camera picks this up, is if you rapidly wave the LED back and forth, you can actually see the pulses of light from the pulse width modulation. Because it pulses on here and then turns off, and in the next time it takes to send the next pulse, the LED has moved over here now. So it'll really bring home the pulse, the PWM that's going on in a visual way. I'll leave you with a challenge which is fairly advanced and will make you think through things. Add 2 push buttons with pull-down resistors, so they are active high buttons. That is, they send a digital high to the input when you push the button. Rewrite your sketch so that rather than fading up and down automatically, when you push one button, it brightens the LED, and the other button dims it. So there's several things to mention. You can just use the fade sample program to get you started, and just make sure you save it as a completely different file name so you don't accidentally overwrite your fade example program. I'd also suggest that you just ignore debouncing of your buttons for now. Just compensate so that pushing a button once increases or decreases your PWM value by only, say, 5. And then that way, if you get 3 or 4 bounces, you're still only increasing the brightness by, say, 15 or 20. If you use a high number like 30, and you get a few bounces from one push, you might be increasing your brightness by 90 or 120, which is taking steps almost half of your maximum scale. So don't forget to check to make sure that you don't try and send a negative number to your analog write, or a number bigger than 255, which is the maximum that you can write.